Hello, in this video we're going to talk about a theorem and a corollary. So the theorem says that if theta is the angle between vectors A and B, then the magnitude of A cross B equals the magnitude of A times the magnitude of B times sine of theta. Okay, so this is a very helpful equation to know and use. All right. A corollary to this says that two non-zero vectors, and that turns out to be very important, two non-zero vectors, A and B, are parallel if and only if A cross B is 0. Let's take a look at a proof. Okay, so let's assume that A and B are non-zero parallel vectors. And so if they're parallel, the angle between them must be either 0 or pi. And we can actually strengthen this. It's not even just an if-then. This is equivalent. So if they're non-zero parallel vectors, or they're parallel, that certainly forces theta to be 0 or pi, or equivalently if theta is 0 or pi, that's equivalent to them being parallel. Okay, and so what this means is that A cross B, magnitude of A cross B, it's the magnitude of A times the magnitude of B, neither of which are 0 since A and B are non-zero, times the sine of 0 or pi. So if we put in a 0, this whole side is 0, and equivalently if we put in pi, still sine of pi is 0. Okay, this is helpful for looking at the area of a parallelogram. So let's recall a parallelogram is a four-sided figure with four sides which are parallel. And the way we compute the area is we look at the base, I'll call that B, and we look at the height, which is perpendicular to the base, I'll call that H, and so the area of the parallelogram is just H times B. Now let's look at the same picture but through the lens of vectors and connect this to the cross product. Okay, along the bottom edge, what was our base, I'm going to call this a vector. I'm going to label this vector B. And this other side, I'm going to call this maybe vector A. Okay, and so if we drop a perpendicular down here, this perpendicular height, that actually turns out to be the quantity, the magnitude of A sine theta. So that's that perpendicular that we want to drop down, and theta is the angle between vectors A and B. And so the area of the parallelogram turns out to be that height, which is our magnitude of A times sine theta, all times the magnitude of B. Putting that together on the right-hand side, that looks familiar. That's the magnitude of A times the magnitude of B times sine theta, and that is equal to the magnitude of A cross B. In other words, the area of the parallelogram can be found by computing the magnitude of the cross product.